Alright, so in this video we're going to talk a little bit about technical drawings, and this stuff is mostly going to be a review from what you learned last year in your introduction classes. So a lot of the stuff from Studio, things like that. So let's dive in here. Alright, overview of drawing types. Okay, so in architecture and interior design we deal with these three primary types of drawings, okay? First, the most common type is orthographic. An orthographic drawing is usually just a flat drawing, such as a plan, a section, or an elevation. And then we also use isometric drawings, and these are more common with architectural diagrams and presentations. And then lastly, we use perspective drawings, and these can be either 1-point, 2-point, or 3-point perspectives, okay? So if you look over here at this list that I have, we can see at the top, under multi-view, we have the orthographic drawings, okay? And here we can see the application, and they're using a cube as an example, but basically you can see that the plan and elevation right here, so this would be a top-down view of the cube. Right here, this would be one of the sides, and then this would be another side. So when you look at it, basically you're just looking at a flat plane, and you're not seeing more than one face of the object at a time. In a more realistic or practical application, you can see that, in an interior you would see the floor plane here. Here's an elevation, and then here is a section. Okay, moving down, we have what are known as paraline drawings, and all of these are used, but I'm only really going to talk about isometric because those are a lot more common than the other two types. Okay, so an isometric drawing, good example of it right here, just a cube, and the focus point is right on this central intersection at the corner. And every single line is drawn at the same scale, okay? If you look down, you can see what I mean by that, how there's some distortion that's going on here. Not every single face is represented the same way, but in an isometric drawing, each face of the object receives an equal level of emphasis, okay? And here you can see in terms of like an interior design application, we can use isometric drawings to show cutaways, angled views of spaces, and these are usually, like I said, more used in a diagram sort of way or a presentation sort of way, not necessarily something that we're going to use in the technical drawings that we'll be producing. All right, and lastly, like I said, perspective, as we move down here. 1-point perspective, you can see sort of the small image here. It's sort of just one point that converges. Okay, and then moving down, we have a 2-point perspective, which is probably the most common type that you'll be dealing with, and that's where 2 points of the drawing converge at the horizon line. And then a 3-point perspective is similar, except there's just an extra level of distortion where the z-axis or the vertical lines are all converging at a single point, which is somewhere up in here. And as we progress through this slideshow, there's going to be more specific examples, more detailed examples coming up. All right, so just to reiterate, orthographic drawings, orthographic projections, they represent three-dimensional forms or construction by projecting lines perpendicular to the picture plane. Okay, so picture plane, that's a word that you probably ran into last year. Basically, that's just the plane that represents the user's point of view. All right, these are completely flat drawings. There's no perspective on them. Each drawing represents a single side of an object, and examples include plans, sections, and elevations. All right, so like I said in the previous slide, here's the front elevation, and then those lines get projected up, and then the top view right here, which is what we call the plan, and then projecting the lines to the side gives us the side elevation right here. All right, isometric drawings. This is a type of paraline drawing, most commonly used, and it's the most commonly used paraline drawing type for architecture and interior design. All three axes, X, Y, and Z, receive equal emphasis. That's basically what I just said in the last slide, but what I mean by that, to reiterate, is all of these dimensions, here to here, here to here, here to here, here to here, they're all the same, they're all equal. So each face of this object is receiving an equal level of emphasis and representation. All lines parallel to the axes are drawn true to length and at the same scale. And they're commonly used, like I said, for architectural diagrams and presentations. All right, perspective drawings portray three-dimensional form or construction by projecting all of its points to a picture plane by straight lines that converge at a fixed point representing a single eye of the observer. Okay, so that's kind of a word salad, but basically what that means is it's just a person with a point of view who's looking at something. Just think of it that way. It's your perspective looking at a particular object from a single point of view, and that single point of view is your eye, okay? The parallel lines can converge with one another at 1 point, 2 points, or 3 points, and these are commonly used for architectural renderings. So perspective drawings, they're important to us for this semester, but they're a lot more important next semester when we get more into 3D modeling and rendering. So we might touch on these a little bit in this course, but definitely next course it's going to be a lot more important for you guys to know about. All right, so I would say that 2-point perspectives are the most common type of perspective you guys will be utilizing. 1 point would be the next most common. And then 3-point is actually probably the most common type in general. Like when you see a photograph of like a building, usually that's a 3-point perspective, because a 2-point perspective is actually a bit distorted to make all the verticals totally perfectly straight, as you can see here. We usually like to use 2-point when we do architectural drawings because it just makes the building design look better. But 3-point perspectives are usually what you'll encounter like with an actual photograph, okay? Just to reiterate, here's a little bit better of an example of that. Here you can actually see the lines converging. So this is the same object. It's a desk, and it's drawn with the 3 different projection types. So 1 point, you can see that all the lines converge at a single point out here. 2 point, they're all converging either to the left or the right at the horizon line. And then 3 point is sort of a combination where they're converging at the horizon still, just like 2 point, but then you can see there's some distortion that's also causing them to converge here, way down here at the bottom somewhere. All right, so moving on, we're going to talk about specific construction drawings, and this is what the course is a lot more geared toward. Okay, and these types of drawings are all related to what we just talked about, okay? These are just more specific types of the orthographic projection and things like that, okay? So floor plans, these are orthographic drawings, and they're drawn from a top-down view. And they represent a single level of a building, okay? So whenever we draw floor plans, we're usually going to have a floor plan drawing for each level of the building, okay? So like a first level floor plan, second level floor plan, third level floor plan, and so on. And these are essentially just a section drawing that cuts through a building at 4 feet above the specified level. All right, so this picture right here is a really good explanation of that, really good visual explanation. So you can see here we have the knife, and that's cutting right through the building here. And the black poche within the walls is what is indicating where that cut is happening. So if we look at our floor right here, the height from the floor to where that section is happening within the wall, that's going to always be at 4 feet, all right? That's the standard for whenever we draw objects within a floor plan. So anything that is under that 4-foot line, like here it's very small, but you can see like a little bathroom sink or like this countertop here in this kitchen. Anything under that line is going to be included on the drawing, okay? Anything above that is going to be left for a different type of drawing, which is a reflected ceiling plan most likely, and we're going to get more into that in a little bit. Okay, so floor plans rely heavily on line weights and pochés to differentiate the different objects that we're representing on them. These objects include things like walls, stairs, and appliances. Okay, so what I mean by that, if you look at this, here we have an example of a poché or a wall fill, which is indicated by this black fill here within all the walls. And this is used to provide an easy designator of what is wall and what is not. So if we didn't include any kind of poché or hatching within our walls, then it would be a lot less clear to the person looking at this plan, you know, what is a wall. It's just a bunch of lines at that point. What is a wall? What is a stair? You know, this is the stair right here. What is an appliance? You know, the toilet and the tub, or furniture. So these are probably beds right here. You know, what do all these lines mean? If we don't provide, you know, a hatch or a poché or some extra level of line weight to differentiate the objects, then it becomes a lot more confusing to understand what the things in the drawings are. And there are different types of floor plans as well. So here we're just seeing a general floor plan view. It's showing furniture, but it's also showing, you know, the appliances and things like that. But we also have what are known as construction plans, and these usually have, you know, a bunch of dimensions on them, and those are for the purpose of actually building it. So you're going to see construction plans a lot within construction set documents. These are basically what you think of when you think of a floor plan. Okay. Next, we have furniture plans. And furniture plans are just like a construction plan, except they don't have the dimensions and they have all the furniture layouts included. And then after that, we have demolition plans. And a demolition plan is basically a plan that shows existing conditions of a building. So these are used a lot in renovations. And usually you'll draw the existing plan, and then you'll show things like walls that are to be demolished, and these will be represented with like a dashed line or something instead of like a solid fill like we're showing here. And then there are a bunch of other types which we'll get into later in the course, but just to summarize, these are 3 common types. And then, let me go back. Any floor plan is usually drawn at either an 1/8 inch scale or a 1/4 inch scale. They can be drawn at other scales, but really it depends on the size of the building that you're dealing with. Usually an 1/8 or a 1/4 inch is the most common that you'll see. Alright, so now reflected ceiling plans. These are plans that show lighting, HVAC, HVAC being like your air ducts and diffusers, ceiling types and other ceiling components. So by ceiling type, I mean, is it a acoustic ceiling tile ceiling? Is it a gypsum wallboard ceiling? All of that information is going to be shown on this type of a plan. And these usually include a legend to show what the symbols, the drawing symbols on the plan actually mean. Okay, so here in this example, you can see the symbol legend, and it's a little bit hard to read, but basically we can see right here, this is a hatch that represents if it's a drywall ceiling. This pattern here is representing a 2x2 ACT ceiling, so acoustic ceiling tile. And if you look at the drawing, you can see that here. So this grid is the actual ACT ceiling. These rectangles are representing troffer lights, which are basically just lights that you place into a ceiling grid. Okay, so we can see we have 6 of them in this room. Oh no, we have 5 of them in this room, and then this one is some type of an air duct. Oh no, that is an emergency fluorescent light fixture. But basically, those are indicators of different types of lighting fixtures. And then we have other things such as wall sconces. And then, we might also have like sprinkler systems, things like that. These little circles over here in this part are representing can lights that are placed into the ceiling. And then these sort of like arched lines, these are showing the actual electrical circuit connections between all the lighting fixtures. All right. And then they terminate here on the wall, and where these terminate actually shows where the light switches are within the room. A lot of the times they also include dimensions. So if you look over here, you can see some dimensions, and the dimensions are really only used on fixtures that are within like gypsum wallboard. So right here is a drywall ceiling or gypsum wallboard. And since there's not a good indicator of where these lights would be placed, they add dimensions like this 2-foot dimension away from the wall right here. And then this is also a spacing dimension between the two fixtures, all right? When you're dealing with an ACT ceiling, like one of these ceilings over here in this area, usually you don't need to worry about including dimensions because these are almost always on a 2x2 grid. So just looking at them, you can usually tell where the lights fall within the room. And these types of drawings are usually drawn just like floor plans at either 1/8 of an inch or 1/4 of an inch scale. All right, next we have elevations. An elevation drawing is an orthographic drawing that shows the vertical faces of a building. We can either have interior elevations or exterior elevations. So over here on the right, you can see here's an example of an interior elevation, and this one is showing the elevation of kitchen cabinetry. And then below it is an exterior elevation, and this is the elevation of a dentist office, all right? So elevation drawings are used to show vertical features that cannot be represented on a floor plan. And these things include things like materials and objects that are above a floor plan's cut line. So like I said earlier with the floor plan, we have that 4-foot cut line that designates what is going to be shown on the actual floor plan drawing, and anything that is above that cut line is not going to be drawn. So for example, these upper cabinets might not necessarily be represented on the floor plan. They could be with like a dashed line, but usually you would refer to the elevation to see the exact placement and dimensions of those. All right, and then another thing to note about elevation drawings is they only include vertical dimensions. Okay, so as you can see on the kitchen elevation right here, we're only seeing the heights of the different objects. So we see the height of the countertop, we see the dimension from the bottom of the upper cabinets to the countertop, and then we see how high the actual cabinets are, as well as how high the actual space is from floor to ceiling. All right, the reason why we don't show the horizontal dimensions is because that information is already shown on the floor plan drawings, and we don't want to be redundant with our information. So the goal is to be as concise as possible and not repeat yourself a bunch of times. All right. They also include annotations that describe different design features. Okay, so over here on the right side, you can see an example of that. Here we have an annotation that's saying that this arrow is pointing to drywall or gypsum wallboard. And then below that, we can see that these sets of lines right here are actually representing a wood cap that's made of maple. This one right here is pointing to the countertop, and it's telling us that's made of corian. And then we can see that the cabinets are made of maple. Another thing we can see within the interior elevation drawing is these dashed lines right here. And they're kind of in a diamond pattern, but what this is showing is the way that the actual cabinet doors are swinging, all right? So the actual point where these two lines come to a point, that's representing the hinge side of the cabinet. All right, so here we can see that this one's going to swing from right to left, left to right, right to left, left to right, and then left to right. Okay. Looking over here on the right side where the floor plan elevation symbol is, this is what you'll see on the floor plan, this little symbol right here. It looks like a circle that has an arrow sticking out one side of it. It can either look like this with just one arrow, or it can have multiple arrows. So there could be an arrow right here as well, or right here, or right here. And this is just, these arrows are pointing to the actual walls that the elevation is being shown of. All right, so this is pointing out the direction of the view right here with the arrowhead. And then the number on top is the number of the elevation. And that is just to refer you to when you're looking at the sheet. So right here, this is the sheet that the drawing is located on. All right, so 1 and 4. All right, so we know that to find this elevation, if we're looking at the floor plan, we need to go to sheet 4 and we need to look at elevation number 1, and that's where we're going to find this on the drawing set. That might not make a lot of sense right now. But as we go forward and discuss floor plans more in depth and actually, get into drawing some, it's going to make a lot more sense to you what this is actually describing. All right, and elevation drawings are usually drawn at 1/8 of an inch or 1/4 of an inch. All right, next we have building sections. So a building section is an orthographic drawing that represents sort of a vertical slice through a building. Here is a really good illustration of that. As you can see, we have the knife and it's cutting right through the building, and then the poche line is showing you exactly where that cut is happening. All right, and if you look over here, you can see that a little bit better. This is the actual orthographic representation of the section. All right, and the poche, like I said, that is showing the actual walls and floors that are being cut through by the section. Longitudinal sections are sections that cut through the longest portion of the building. All right, so if we look at this is actually like a plan representation of a building, like a very simple one. But this line right here, this is representing a longitudinal section, and then this one right here is what's called a traverse section. And a traverse section is also known as a cross section, but basically it's a section that runs perpendicular to the longitudinal section. All right, and whenever you see building sections, they'll be indicated by these symbols that are shown here. It basically just looks like a line that has a triangle at either end of it. All right. And section drawings are usually drawn just like the other kinds of drawings at 1/8 of an inch or 1/4 of an inch scale. All right, so last up, we have what's known as detail drawings. And detail drawings are basically just a specialty drawing that is used to show construction and design features. A lot of the times you'll see detail drawings that are of things like millwork, cabinetry, stuff like that, where it has a lot of small features that are hard to represent in a different type of drawing. So usually these are just enlarged sections or elevations. They can also be plans, but a lot of the times they are sections or elevations. And as you can see, they include dimensions and a lot of detailed annotations that describe the exact construction of whatever the drawing is of. All right, so in this example, we can see a cabinet section, and it's showing us a section through the side of a cabinet. We can see the wall here that the cabinet is attached to. We can see exactly how high that cabinet is, and then we can see what all these different pieces that build the cabinet are. All right, so we can see that we have a rubber base here. We have cabinet doors. We can see that the material is a plastic laminate. And then below that we have a millwork section. And this is just showing us some detailed casework. So we can see molding profiles and things like that. And we can see exactly how large each of those are. And over here are the actual specifications of those different moldings. All right, so detailed drawings are usually a lot bigger than the other types of drawings that we've talked about. And they can range in scale from an inch equals a foot all the way up to 3 inches equals a foot. But they may also come in a variety of other scales, and it all just depends on what they're representing. All right, so to explain these different types of drawings a little bit better, I wanted to show you guys a more practical example of an actual building model. This is a model that I made for an architect on the side, and this is made in a program called SketchUp. I'm sure many of you know what SketchUp is, or probably have used SketchUp in the past. But this is going to give you guys a lot better of an understanding instead of just looking at those 2D drawings that I had in the PowerPoint. All right, so starting off here with this view of this house, this is a 3-point perspective view. So we can see that lines are fading out here on the horizon to the left, to the right, and then also all the vertical lines, although it may not really look like it, they're all converging at a point way down here at the bottom. So next, if I toggle to the 2-point perspective view, you can see what that actually does. Okay, so as you can see, looks a little bit different, but now all the vertical lines are perfectly straight. These lines are converging over here to the left, and these ones are converging to the right, but the vertical lines do not converge at all. They just remain perfectly straight. All right, next we have an isometric view. So if you look at the isometric view, basically that is perfectly focused on the corner point of the building at an angle, and every single face of the building is represented equally, and they're all shown at the correct scale, proportional to one another. All right, next we can go to a floor plan, and you can see as we go to a top-down view, we get our section cut that cuts away the building, and there's not really anything inside this house right now. It's basically just the shell of the house. But you can see our black pochette line that appears to designate what the walls are. And then anything below that line is being represented. So although there's nothing inside the house, you can see that these different sets of stairs, the floor, the ground outside, this flooring material that's inside this little area here, all of that is being shown on the floor plan drawing. All right, next we'll go to a longitudinal section of the building. All right, so here you can see that that is a section just like the floor plan, but it's cutting vertically through the longest point of the house. All right, and sections are really useful for showing us things that might be hard to see within other drawings. And the point of the section within this project is to show this sort of atrium outdoor space in the center of the house right here. Without that, it's really hard to see what is going on inside of that space, which you'll be able to see from the next view, which is the elevation views. All right. So if we go to a side elevation view, this is an orthographic view. And that means, like I said, it's totally flat. We're not seeing any other sides of the house. We're only seeing this side of the house right here. And because of our elevation view, we cannot see what's going on right here inside of that atrium space that we just looked at with our section cut. We also have the other elevation views. Like I said, you would have one elevation view for each side of the house if you're doing an exterior. So here we can go on to the other long elevation, and then we also have the 2 short elevations, okay? All right, so we're representing each side of the house within our elevation views.